Welcome to the Trellix Spotlight series. My name is Nick, and I will be your host. Today's session will focus on Trellix XDR and supercharging your searches with the Trellix Query Language. This webinar will be recorded. If you prefer not to participate in the recorded session, please feel free to disconnect at this time. A link to today's recorded presentation will be emailed to all registered attendees. This webinar is a brief overview covering common use cases and scenarios regarding this topic. It is not intended to be all-encompassing. If assistance is needed, please contact Trellix Technical Support. If you have questions during the webinar, please type them in the Q&A window. This webinar may run longer or shorter based on your participation, and we recommend asking as many questions as you can to make the most of this series. If the Q&A window is not displayed, click the tab at the bottom of your session window and click on the Q&A icon. We will answer the questions during the final section of this webinar. If you experience any audio issues during the webcast, please drop and attempt to reconnect. Our presenter today is Sarah Cox. Sarah is an instructor and curriculum developer at Trellix with over 20 years of experience working in technology and security. While at Trellix, she is focused on digital forensics and incident response. Sarah has a passion for teaching and is also a faculty member in the Cybersecurity program at Numeric College in Oakland, California. When she's not working, she enjoys hiking, biking, and most of all, skiing. Ladies and gentlemen, Sarah.
Thanks, Nick, for that warm introduction. I am so glad to be with you today to discuss Trellix XDR and how we can supercharge our searches. And we're going to dive right in. First, we'll begin by introducing the tool, XDR, talking about kind of the architecture of it and how we're getting data into the environment and what we can do with it. And then we'll shift very quickly into talking about searching. We'll start at the beginning with the search basics and working with the UI, and then we'll introduce many, many examples for Trellix Query Language to see how we can build complex searches to identify the data in our environment that is of interest and that we're looking for. That'll include things like building out transforms and pivoting and grouping, and we'll show a ton of examples so that you can leave this webinar feeling much more confident in using that search functionality. We'll have some downloads for you at the end as well. You'll be able to download a copy of these slides, and we'll have a quick reference guide that you'll be able to download. It's a one-pager with examples that you can use as models to build the searches in your own environment. And then finally, we'll wrap up with some of the features in XDR that make it easy to work with search, so saving and repeating searches and running them on schedules. So with that, let's jump in. First, I want to just lay the groundwork here. We're dealing with Trellix XDR, and for today, we'll be working out of our Trellix Helix tool. It is one of our products that falls under the XDR umbrella, and all of what we're showing here from the search syntax and the pivoting ability, that is going to apply in Trellix XDR as well. So let's look at where this sits in our architecture. Across the top here, we see our one console, and Trellix XDR is a part of our X console, and it's going to make it very easy to work with our tools seamlessly. And we'll really get some great experience working in that today. But I want to step back and talk a little bit about the foundation that is feeding into that, and that gives that the power to do its job so well. Starting at the bottom, we'll talk about the data lake. The data lake is comprised of billions of sensor detections from our appliances deployed worldwide across our different core engines, across endpoint, across network, across email, across cloud and data. And we're using that to power our solutions for our customers. We're also taking all of that data and having our Trellix Advanced Research Center, which is a team of hundreds of experts, data scientists, threat researchers, software engineers. They have a mandate to leverage this data from those sensors and direct automated response and build best-in-class detection. We're really proud of the work that they do. We have a section of our website dedicated to publishing their research. It's a really wonderful resource on top of the intel that they feed back into our products. And we talked a little bit about those core engines, looking at activity across different areas of focus. And all of that is feeding into our XDR solution. Now, equally important to all of the great work that we're doing here at Trellix, I do want to make a point of calling out their integrations with these third-party engines, because we know that in your own environment, you're working with a myriad of tools, and those tools need to work together seamlessly. And we have a commitment to working with that third-party data so that you can use all of it in this XDR architecture. So with that, let's take a closer look at how we get the data into the tool and what we do with that. So here we have our XDR workflow from collection through action. So starting out, we do collect data from all of the important resources in the modern enterprise. And we know that enterprises are complicated, and as resources have been pushed to the cloud, teams have become dispersed through remote work. The attack surface has expanded, and we need to keep pace with that. So we're able to collect the data from those various sources. And as we ingest that, we can ingest data not only from the Trellix toolset, but also data from over 1,000 different native and open security tools. And we're really proud that this number is growing continually, and we have a commitment to working with those outside resources. As we bring this data in, this data is parsed and normalized using the Trellix taxonomy. Essentially, what this means is we get logs with various formatting and sources, and we're going to be able to recognize an IP address as a source IP and map that, as you would expect, to a single field. And that normalization is really essential for us to be able to build correlations across the disparate data types that we have. This is a really important step, and we'll talk in a little bit more detail about that parsing process, as we call it. Once we have the data, we have multiple detection engines that are operating on that data, identifying the latest threats. We have our rules engine that is looking at incoming events and looking for specific types of attack activity. We have an analytics engine, which is looking for behavior anomalies within the data. And we have our user and behavior analytics engine that is looking for patterns across users and hosts to identify attacks and, again, correlate that activity. From our detections, we can introduce the automated response. We provide pre-built playbooks that'll help you standardize your investigation and response process. You also have the ability through Trellix Automated Response to build your own playbooks and drive automation and efficiency. And then in our tool set in XDR, we're going to give you the ability to investigate and respond to threats and take action. So for example, if you are working with your EDR solution, your Trellix EDR, you'll be able to terminate processes, delete files off the system. If you're working with endpoint security HX, you can use that functionality seamlessly to contain systems right from our XDR console. So really cool stuff going on here. Our focus today is to talk about search. And so to do that, we want to really understand the parsing process. As we get events into our environment, we'll receive those as raw data, and we'll retain that as you would expect. So we always have the ability to search that. And then from that data, through that ingestion and normalization, we'll parse out different data types. So all of the content in that raw log, we're going to map to our taxonomy to specific fields like the HTTP method or the source IPv4 or the source port or the URI. And so we can see a mapping from that raw log to those parsed fields. Now you'll notice at the bottom of the screen with the fields that are parsed, we have more data there than what has been mapped to the raw message. So at ingestion, we also apply metadata. So things like applying a unique ID that we can use for tracking. We're applying the name of the sensor that sent that data by the COM broker ID, CB ID, or COM broker name, CB name. That's going to help us operationally understand and make sure our data is healthy. We're applying a timestamp of when this event comes in for ingestion. And if we have matching, right, if we had some detection, like we see here in the bottom left, we have this timestamp, meta RTS, and then next to it, the meta rule. So this particular event actually triggered, matched a rule that we had, and we append data about that rule match right to the original event so that we can move through all of our data and understand all of the connections that we have with it. At the same time, we'll also apply geolocation data when we have it available for that event type. So you can see here we've applied fields describing the destination city, country code, and so on. And we'll talk a little bit and show some examples of all of this. I also want to point out that at the top in the header here in gray, we've got a class, which is the Bro HTTP class. So that essentially describes the type of data and source. This is coming from a Bro sensor. And we also apply a meta class. And if I jump back to this metadata, we can see in the bottom right field that meta class is HTTP proxy. So that meta class is going to span, different specific data types, Bro being one type of HTTP data that can send. The meta class is a bit more broad. And that class and meta class can be really helpful when we're searching. All right, so all of those fields become searchable. We can search the raw log or we can search any of these individual fields. So with that, let's jump in and start to talk about search. So when we come into the UI in Helix specifically, we can always click on that magnifying glass in the top right corner to bring up the search pane. In your Trellix XDR tool, that search pane is going to be there standard by default at the top of every page. And if we don't have a great handle on the syntax, we can always just do a keyword search. So here we've entered the term Google just to have something to get our matches back. And you can see we get hits from that because we have events in our data that we've collected that match Google, as you probably expect. That's a pretty common source. And so we get the events back, and we've got a list. We can see the first event here, and we'd see subsequent events below that. In fact, we can change or toggle between that list view, which is the default view, or view our data as a table. And then we see that in a bit more of a condensed format, and we're going to specify the fields of interest so that we can make some comparisons. Another way we can help with the display of our data is to use the filters. So there's a little arrow on the left side of your screen that'll slide that filters panel out, and then you can control which type of display you're using, whether you're only seeing the raw log, you're only seeing the parse logs, or both. Do you want to see the metadata? Do you want to see the geodata? And this is not affecting, the actual returned results. It's just affecting what we're displaying on screen. And from any event result, whether we have a field of interest or a value of interest on that field, we're going to be able to click on that and generate what we call pivot searches. So we could take this user agent, if it was of interest, and start a new search from that, or refine our existing search by adding this to the current search, or grouping, doing exclusions. So we can start to build up a more complex search simply by finding values in our event results of interest and going from there. That's a great way to get started using the UI and starting to build up more complex searches. And then as we get more comfortable, we're going to be manually updating them or manually keying in. So let's jump into Helix and take a look. All right, so here we have our console. I'm going to bring up the search pane. And as we saw earlier, I could just type in something like Google, and that's going to search for my results. I didn't change any of the defaults, so it's looking over the past 24 hours. And you see we get our list of events. I can slide out my filter panel here. Right now, I'm only showing the parsed data, but I can show raw plus parsed to see both of those. And in fact, in the raw message, we've got this selection to highlight matches right in there. Now, another way we can search our data, and I'm going to go back to that main dashboard just by clicking on our logo here at the top. If we're unsure or wanting to start to familiarize ourselves with our data, a really great way is to start on this detection dashboard. This dashboard is a really handy starting point for consuming our asset-based alert correlation, viewing recent alerts, which are loading here, viewing our open cases. But what I'm going to do is actually scroll down to the bottom. And as we're just starting out, let me check my zoom level, we're good. This is a great place to start because we may have data in Helix that we're deeply familiar with as a data source. And our question is, how is it represented in our tool in Trellix XDR? So I'm going to just pick one of these event classes. I'm going to pick the FireEye NX class. These come from the Trellix Network Security product, which is a network detection next generation firewall product that we can deploy on our network. And because of how we deploy it, it has network traffic visibility. We can enable the evidence collector module on that to collect events and feed data into XDR. So I've just clicked on that class and it auto-populates my search. I really love how easy it is to get the tool to build out our searches for us. This is a pretty straightforward search, but I'm just going to run that from there to get some events back. And you can see the filters we set previously stand, showing both raw plus parsed. So let me change that to just those parsed events. And now we see the various fields that are included in this event class from FireEye NX. Now I could choose to show or display those geolocation details. And when I enable that, I do start to see now in my event, I've got the destination IP, I've got destination city on this one, country code. And so that data is always available for searching, but it could be useful to view. I can also enable viewing the metadata, and then we see those metadata fields like the COM broker name, meta CB name, the CB ID, and some additional timestamps. And here I can also change my view from list to table. And we start to see our events now formatted as a table, and I'm going to collapse that for a little bit more visibility here. And in this table view, I can make adjustments, right? So this is kind of the default view, but I might choose to hide this raw message host name because it looks to be empty, or the program, again, that looks empty. So I can make refinements and then save it. For now, I'm just going to revert the layout and go back to that list view. So we can also change our view here. All right, so we've got our FireEye NX class. I also want to make sure to show the pivot. So I am going to find in this data the event type field. Here we have flow. And so the event type describes the kind of type of metadata that we have for our network. So in this case, I want to group by field so I can see the distinct values of event type. And so we see flow, DNS, TLS, and so on, and we get a count of those events. So that's the group by, and we'll go into more detail. I'm going to talk about a lot of different ways that we can customize that group by and really make it work for us. But for now, I just wanted to show how straightforward it is to start to do your searches in the web UI and use the tool to build those out for you. So we saw with those searches, the tool is starting to build up that search syntax using the Trellix Query Language, or TQL, and it's building it automatically, and it's building the proper syntax for us. What I want to go through now is show you a bunch of different ways to customize that and extend it by manually editing or adding clauses to make those searches more complex and work for you. And we do it's really important to understand TQL. We see it in lots of different places in our XDR solution. So we're going to spend most of our time today looking at search, because that's a great way to just test and make sure that our searches are working properly. But we'll see these queries reproduced or used kind of in various other places. Just to call out as a note, we do have a syntax help just tucked underneath the search bar that you can use if you need a little bit of support writing your searches. Also, just as a resource at the end of this webinar, we'll give you a link to our programmer's guide for TQL, which is on our docs portal, which is another great resource. So as we'll see, you're going to use search in the search function itself. We also see it in dashboards. Dashboards give us the ability to create a collection of searches and tie in visualization. It's a really great reporting mechanism, either for getting like a snapshot lay of the land, or we can turn those into actual reports that get scheduled and emailed out. And then we'll also see the searches in our rules and detection. So if we have an alert that comes from a rule, you'll always see the query that triggered that alert. And you can see here the syntax, the logic of it can get pretty complex. So we want to have some comfort level with TQL so that we can interpret those correctly. So as you would expect with any good query language, we support the kind of basic logic functions. You can AND your fields, you can OR them, we can do exclusions. In fact, with exclusions, we can write out the word not, or we can use that C-style notation with the exclamation point. And for data that's numeric, we support the mathematical operators as you would expect. So let me just talk through these examples. In the first one, it's an example of an AND. And so events that return will have to match both of those criteria, both the source IPv4 and the destination IPv4 that we indicated. In the second example, we're using an OR. We have an IP address or a domain, and so we'll get events that match either of those. So we get a kind of a larger data set there. And in this third example, we've got events with the destination IPv4 that we've listed, but we're excluding the source IP that were listed. So in this case, maybe we're looking to identify new systems that have contacted that destination IP. We already know about that initial one, and we want to see what else has been involved. And then in this last example, it's an example, or the idea being that we're looking for large outbound flows. Now, the large, we're going to set whatever threshold we're interested in, but we can do those numeric operators on the data when it's numeric. So that's all pretty straightforward. We also have different ways of kind of indicating how we want to do a match. So we can use the equal sign for a strict match. And in this first example, we're looking for events where the domain is google.com. It has to be exactly that phrase. And then instead of using the equals, if we use the colon operator, that's looking for a match. So the domain simply needs to contain google.com. Now this is tokenized. It's not just searching anywhere for those characters. And I'll show you in the tool kind of what that means. So we kind of have to see google.com in its entirety. Next, in this third example, we're looking for events where the domain ends with google.com. So we're again using the colon operator because it's kind of a partial matching. And then we're using the asterisk for a wildcard. Now this wildcard has to be either at the beginning or the end of the value that we're looking at. It can't be stuck in the middle there. So we do prefix matching or suffix matching. If you wanted to get more complex or with our matching, we can use a regular expression. Our search syntax supports the Perl compliant regular expression, and we have a very straightforward example here, just demarking the expression with the 2 slashes. We're not doing it too complex on this one. So let me run those searches because I think it's really interesting to see the number of domains coming back and how that's affected. So I'll start with domain equals google.com. And in this environment, because we just have a test environment we use for training and for these presentations, there's not a ton of data. We actually just get one and only one event back. But now let's change that from an equals where it has to be google.com to just containing google.com. And when I run that, I get quite a few results, right? We're up to 1.5 thousand. And in fact, it's probably going to be helpful if I group on the domain, so I can see the various domains that were included in that data set. So when I group by domain, I can see, okay, yeah, www.google.com, that contains Google. That second one's kind of funky, apis.google.com. And so we can see how that partial match changed how that search was interpreted. Now, if I add the asterisk here for having to end with google.com, trying to see if there's any here that don't match that. Oh, this one, www.google.com/training. Again, that's a funky one that doesn't actually end with google.com. So I think we're going to go from 10. We'll probably decrease here. So yeah, now we have 9 different values. So that one doesn't match the format of ending in google.com. So we didn't get it. Now, just to show you here, we can't just do Google, with the asterisk kind of generic because, oh, these two start with Google, so that will work, but it's only matching from Google at the beginning to the end. And I don't think we can't do 2. That breaks it. So if we want to get like more have more options with our matching, we would introduce the regular expression here. And so then this is going to match anywhere the field contains Google, anywhere in it. We haven't anchored this anywhere. And in fact, we don't even have to do that full phrase, right? Anything that has the GOO in there. And here we get googledomains.com, right? So we can really just by updating the operator and maybe using wildcards or partial matching really change the type of data that we're getting back on our searches. So do keep that in mind. All right, let's jump back to some examples, and we'll keep this flow of showing some examples in slides and then seeing it live in the UI. We can search across multiple values. In this first example, we're looking for a few host names, and we could write this out in a long form, right? Host name equals win10, or let's call this host 1, or host name equals host 2, or host name equals host 3. But first of all, that gets long and it's a little harder to read. In this syntax with the square brackets, we are just going to point at the field, we'll give it multiple values, we'll comma separate the list. And this will be treated with an implied or, meaning any event that matches either host A, host B, or host C will get our results back. And then alternatively, if we don't want that to be interpreted as an or, we can insert the ampersand, and that will force those items to be considered or joined with the logical and. And in this third example, we can use that bracket notation to indicate multiple fields. So we're not limited to doing this just on our values. So we're looking either in the source IPv4 field or the destination IPv4 field for that IP address. And we'll see events, either outbound events or inbound events for that IP. Now, as you can imagine, searching your IP data like this is pretty common. So we have an alias that maps to those IPv4 fields. And the syntax for that is the the tilde, and then IPv4, and then we'll indicate the IP address. And that's going to search all fields mapped to that IPv4 alias. It's a really handy one. We have several other aliases that are useful, and I'll go through those in a minute here. And then the last way we can search multiple values is to search a list that we have created. So in this example, we have a list called evil IPs, and we're searching, and that list is always going to have the $sign notation. So that'll be the indication. Now, if you see lists in your interface, we have placeholders for them, and if you haven't created it, it doesn't exist. So just keep in mind that $sign that ties to lists, and you can check out the lists. So let me show you these. Again, we'll jump back into the UI to check this out. And I'm going to start with the source IPv4 example that I used. And fortunately, I prepped these, and so I can kind of fill that from my last run through rather than relying on my typing, which is horrible. So we're going to search either the source IP or the destination IP for that address. And in fact, what I think I want to do on this one is I want to group on the source IP so we can kind of see that that's really giving back the types of results that we expect, right? So multiple source IP. And in fact, we could do this as pairs. So when we do this grouping, we're not limited to just one. So here we see all of the pairs, the source and the destination there. And as I said, we have an alias for that IP data, so I can use tilde IPv4. And I get a similar set of results here. It hasn't changed much because this maps to that source IP and the destination IP, as we would expect. Now, next, I want to show the list syntax. So I am going to do this domain. I think this needs to be an equal. And the list I have created for this is called ransomware domains. I think I have to go back a little further to find that data based on what I know is in this lab. And sure enough, we've hit that. And now what are the domains on that list that we had matched? I can group that to see. I think there's just one because we have to play this activity out. Yep, so we just have one there. So I've introduced lists. This is an amazing feature. I don't want to move too far down the road of talking about lists because we have to get through a lot on search in the time that we have. But if you want to know more about lists, go ahead and check out the documentation or come to that the configure menu, and just under lists here, you can explore some of the content that we have here. Once this loads, we've got the create list option. The UI is really straightforward, so you can you probably be able to just explore and figure it out pretty easily, either from exploring there or looking up and reading a little bit about that list feature. But for our purposes, just know you can set up a list and have that data retained to use for searching multiple values. Now, we showed the IPv4 alias. We have a couple other common aliases. So these are just mapping to field names containing similar data types. So we've got documentation that will list out the full list of which aliases we have, but we find these here to be the most useful or most common, things like IPv4, which I showed, IPv6. We can search fields with hostname data, ports, interfaces, and so on. So definitely explore this when you have a chance to get into your own environment. Now we have the how-to on working with lists in the slides because I know you guys are going to get these and I want to be complete, but I did show this in the UI. So that's under the configure menu and you'll just hit the create list button and the UI is going to really guide you through the setup of creating the list and the naming and adding indicators to it. It's pretty straightforward. All right, so I'm going to continue in this manner of giving tons of different examples and showing in the UI what we can do. If we have numeric data, we can search a range of that data. Just note that that's non-inclusive. It uses the angle bracket notation. You can see we've got the range starting from 20 going up to 124 on that destination port, and it's non-inclusive. My mnemonic for remembering that is that it's the angle bracket, which is, greater than or less than. It's not less than or equal to. We also support CIDR syntax for IP data, just as you would expect. So you can use that syntax to search fields that contain that IP data. And specifically for our ISP, we have this set of keywords, private IP address LAN, and it's those 4 words in that order, and that will give us data in our local area network. So that's a good one to know, and I'm going to show you a little bit later how you can set that up as a kind of note for yourself with favorites. So I think these are pretty intuitive. I'm going to skip the demo just to keep us on track for time, and I want to get into talking about grouping. So in our examples, I have showed group bys. We've used that to kind of survey. If we run a search, we can use a group by to see how that data is organized. In this screenshot, we are grouping by user agent. So we're going to see the various user agents in our environment. And here we actually have a bunch of kind of funky looking user agents. These all seem to have this string LDAP. You may be familiar with this. If Log4j ruined your holidays the other year ago Christmas. And so this, we can see folks were probing our systems for that vulnerability. That's not an active vulnerability for us, but it doesn't prevent people from trying to exploit it. So we see that those interesting looking user agents here. And if we wanted to follow up on any of these, because these are data returned, just like in an individual event, we can click on that value and pivot off of it, right? So create a new search or exclude it from the current search using kind of the same functionality. It's the same menu we saw on like individual fields in a single event. And if we wanted to, from this group by, see the individual events returned, we just click on show search results. Also, if we slide out the filter panel on the left, we'll get a visualization of the breakdown of those various group bys. Okay, so with the UI, it's super easy to add this group by, and I kind of showed that as I was in the tool just a minute ago, but we can extend that and do some really interesting things. So the group by transforms the data that we're seeing and kind of groups it based on frequency of occurrence. And if we just do the default group by, it's going to return the top 50 groups, or I should say up to the top 50 groups. And let me jump into the UI here, and you can see we've got just one domain, right? So that we didn't hit the max there, but let me see if I can find, I don't know if I have one here that's going to hit 50. Oh yeah, that one was up to 46. Let me grab one from here. So we're going to do meta class HTTP proxy group by user agent. So here we go. We hit 50, and then the exclamation point here tells us we kind of capped out. So that's the default behavior, but we can tune it with just a little bit of syntax. So if we want to see the user agents that are least frequent, so not the most populous groups, but the least frequent groups, all we need to do is insert this less than sign, and it's going to reverse the sort and show us the groups with the least amount of events. Okay, and here we have just, just one event, and we've still maxed out at 50. And I can also group on multiple fields. I showed that earlier with the source IPv4 and the destination IPv4 sorting. And then we can also adjust the number of groups that are coming back and the thresholds. So if we wanted to see more than 50 groups, we could set the limit not at 50, but let's say at 100. And I can see, yep, I still had 100. And let's see if I went up to like 500. I don't know how many we actually have. We have more than 500, so I could keep going there if I wanted to. So that's the limit. It's dictating how many groups we're seeing back. We could also adjust the threshold. So some of these groups have like over 100,000 events. This is 84. So maybe I'm only interested in events that groups that have 10,000. So there were only 10 of those groups. So we're not seeing all of the results, but we do see the groups. So we didn't cap out on our groups. So with that limit and threshold, we can kind of fine tune the way that we're getting data back. And you can imagine how helpful these adjustments could be for trying to look for outliers in our environment when we're looking at data. So we've got these examples on the slide showing limit, using limit with that reverse sort or adding in a threshold. In the bottom pane here, we have a shorthand where if you don't type out the word limit and threshold and just indicate the numbers, the search will be interpreted. So this will not break anything. It's a quick and easy shorthand. I am a stickler for, I think, rules. Maybe it's because I'm like a firstborn-ish type child with my birth order. So I like to see the limit and threshold written out. I find it very easy to read, very easy to understand. And I feel like seeing the shorthand here might cause confusion. So if you're going to go, this is great for working and searching. If you're going to save the search, I'd say just take an extra minute and type those out so it's very clear what's going on there. We do support other types of transforms, as you would expect. So we can sort the data, we can, ascending or descending. We can sort on multiple fields. We can layer our transforms together by adding a different extra pipe. And then another one that I think is really cool is we can build out the table. So we can see an example here of looking at proxy data. And we saw in the UI, we can format that as a table, but we can bake that table layout right into the search just with that table transform. So let me show that. So we've got our meta class equals HTTP proxy. And now let's imagine we wanted to build out a table with a timestamp, source IP, destination IP, port, and domain. So one of the ways that I kind of cheat and do this is because I find it helpful to look at a sample event and kind of make sure I'm including all of the data. I'm seeing all of the potential domain data that I want in the fields. So I'm going to add that as a group by, and then I think what I can do is add this one as a group by. Oh, that actually replaces it. So let me try this. So I would do table. So I guess I can't layer them, but I can kind of use these for reference to make sure I have all those names right. So destination IPv4, we had domain. We do want to have an event time, so I'll do event time UTC. I'm not sure if this is exactly what we had in our example, but that gets us close at least. And then we have our data, and we can also layer in, as I said, multiple transforms. So I could do a sort, and maybe I want to do it ascending on the domain. And there we have our results back. So I'm not sure that's a search we would need to use, but we can do it with the table format, just with that table transform. We have one other transform type called a histogram, and you can see here the search box looks different. This is labeled as pivot query. We can't run this in search because it actually is tied to a visualization. So we can use this on our dashboards. And I did mention that we use this TQL in lots of different places. So in our custom dashboards section, I'm just going to pull up an example that we have here. I highly recommend exploring custom dashboards. It's an awesome feature. I'm not going to go into full detail on that, or we will not stay on time because there's so much awesome stuff there. But here is an example of that histogram. And if I zoom in a little bit, we can see the beginning of our search syntax, the pipe for the transform, and then that keyword histogram. And for the histogram, we're going to indicate a field that has time value, in this case, meta TS, and then the amount of time we want to graph, in this case, hour. And so with this histogram, because we're on a dashboard that can add visualizations, it builds out this visualization so we get to see the flow of data over time. And this would be really useful for spotting anomalies. So that's the full set of transforms that we can do with the group by. We've got the sort, the table, and the histogram as well. Now we do have some directive clauses that we can indicate in our query as well. The most popular one, the one I see the most often, are time-based with start or end. And we can do that either by indicating the time in the year, month, day, hour, minute, second format. That's that first example at the top. Otherwise, we can do kind of natural language, just saying start, 24 hours, end 1 hour ago. So if we were running this search, we can change the frame just with the UI, and that's going to change the data that we get back here. That was 5,000 events in the last hour. Or I could do, and I think it has to come before the pipe, I could say start 10 minutes ago. And then you can see we get the results really get streamlined. So there's two ways to indicate the time. But the nice thing about putting it in our search is that that potentially becomes repeatable if we're going to save this search off. We have a few other directives that we'll see. I think of these largely as being related to work in the API. So we have a page size, which is going to indicate the number of events that come back. The default is 50. So you can imagine we're running a query through the API. We want to batch those events in kind of manageable sizes. So we might grab 50 events and then loop again and offset by that 50 and grab the next batch of 50. So those directives really are going to come into play with that API usage. We can use them in the UI. We could indicate the page size, but we can also just change our display. So we got those two options. We do have a couple functions that are pretty straightforward, but I really like these, especially the has. We can test that the data, that each event has data. So this has destination city is going to only return events where that destination city field has data in it. It's a really good test. And actually one of the great searches just for like testing and getting starting is just to say, has class, because every event that comes in is going to get parsed into a class. And then, we could group by class and kind of see the breakdown of data in our environment. And actually here, it was the last hour. We saw on the dashboard, we saw that for 24 hours, but you could look back further, right, and see like what's been happening over the past week. So that's a real simple but easy and good search to run. We have the converse of that with missing, so you can test to see if a field does not exist in the data and return those results back. Several of the fields that we append during ingestion, those metadata fields, are JSON formatted. So here we see an example of the assets field. Our assets are built out by our asset discovery service passively from data coming in. So if you've got Okta data that you've sent to Helix, or Azure data that has information about your users, we're going to be able to parse that, and then we'll define your user entities and host entities from that data. And so we see information about that asset in the assets field, as you would expect. And because this is JSON formatted, we need to know the syntax for searching it. So we'll search on the field name, which is assets, and then we'll use the dot notation to indicate the value within that. So let's see that live. I'm going to just run has assets here to give me events that have that field in it. And I didn't change that away from the past 7 days. So let me run that on a shorter time frame just to get a results back quickly. And then I'll find this assets field, and it's JSON, so it's not so easy to read, but if I click on it, I get that pretty print view, and I can see all the details here. So for this one particular host name, victim2, we had a few aliases, victim2, victim2 $, and victim-2.mandiant.com. So different sources are sending data about this same asset in slightly different ways. And so we're able to correlate those and understand it really is the same asset. So if I wanted to search for events related to this asset, I can search for assets and then dot for the dot notation, asset underscore name. So let me do that. So with the JSON field, we do the field name and then we use the dot notation. And I'll indicate that alias that I had there. And so we'll see those events coming back. So just to kind of summarize what we've seen, we have our searches built out of field value pairs, maybe more than one. And we saw things like comparisons, numerical comparisons, regular expression, set notation with that bracket and multiple lists, multiple values, I should say, the lists and aliases. So that's like all the great stuff that we talked about with searches. We introduced the directives. Start and end are probably the most common that you'll see as you're searching and working in the UI, but we also support page size, offset, and limit. And we had several transforms that we discussed. So we had the group by, the sort, the table, and the histogram. Now that we have a solid understanding of all the different ways that we can work with and manipulate our data and build out searches, I want to talk about a couple features that make it repeatable to kind of ease of use with those searches. So the first is the history. As you're working in your environment, running queries, XDR is going to keep track of those in a history. So anything that you've run recently will be found here. So you can imagine you've got a line of investigation, you're running searches, you're pivoting, and you get to the end, you've answered your question. Then you want to step back about 4 steps in your thought process and go down a different avenue. This history makes that really easy. Next, we have the saved searches. And with a saved search, what you can do is once you've run a search and confirmed your results are coming back just the way you want and the syntax is great, you can save it. You can set it to be scheduled. You can save it just to run it ad hoc when you're interested, or you can set it as a favorite. So we click on new search, we get the new search pop-up. We're going to fill in all the data about the name and description. If we want to have it just for ourselves, we will set this to private, and that means it's a search just that I can use. The default is not private, meaning if you save a search, others in your environment, in your own organization can see it. You can mark it as a favorite if you want, and I'll show you where that favorites menu is and how you access that. It's really straightforward. And then you can schedule your search. So if you schedule the search, we can imagine some of the really useful use cases for this. Things like hunt mission, gathering data, that you're going to then review for hunt missions, scheduling searches to collect data for audit purposes. We can do that's just really a helpful, easy feature. So let's take a look at this again in the UI. Now, a few slides back, I talked about this, the search syntax for the destination ISP. I'm going to find my example here because I ran it before we were together. So we've got this this specific phrase, private IP address LAN, and if we run that, and I'll do a group by source IPv4 so we see. I actually want to group that on the destination because I'm looking at the destination here. So that essentially is representing, you know, our hosts and her local network. And so for this one, I'm going to set it as a favorite just to help me remember that phrase and get the exact order right. So I've got my search here, and I'm going to just take that off for what I'm going to save. And then I will save that as a new search. And I will give it a name. I could give it a description, and I'm going to select add to favorite so that'll populate. Now I'm a person who worries about demos, so I've pre-staged this. So at this point, I'm just going to cancel this. And here in my favorites, I have that search. Let me clear this so we can show that's really happening. And I can bring that search up. So that means I can use that as the basis for a search and then build it out. And I don't have to worry about remembering that strict phrase. You can see I've got other favorites listed here that we use, you know, that I use pretty frequently. So that's the favorites. I showed you the history kind of inadvertently because I was looking for something I had run previously. I use this history all the time. It's super handy. I love that that the tool keeps track. If I don't want it, I can choose to clear that history and then it goes away. The other thing I can do is I can just do a save search. So rather than setting this as a favorite, I just keep that clear. I can fill in my search details. I can assign it to a category. I could choose a format for my table if I wanted to, and I have all those scheduling options. Once you set up that search, you're going to go to the configure menu and review those searches. And so here we see searches have been configured previously. For those that weren't scheduled, I can expand the options menu, and you can see I have the choice to run an index search or an archive search. Index search is nearer term in the last 7 days, and it's leveraging those parsed events. It's Elasticsearch. I get those events back lightning fast. If I need to look back a little further in time, like, you know, more earlier than 7 days ago, yes, of course, obviously I can search that data. I'm just going to do it as an archive search. The configuration of that search is the same. It's just the mechanics of how the backend operates it. Now, if we had a scheduled search, let me scroll down and we can see here a few that were scheduled. We've been using this one for a while, running every Thursday. And because it was scheduled, it's been running. And so I can navigate in and view those results. Now I'm actually going to go to kind of the earliest time when we started to run this, because we actually had events then. And you can see that when we ran it, we actually had events collected. So I can download those right from here, and those will be CSV format. So that is the saved search feature. Let me bring our search window back up. I did mention through Save Search, there is that distinction between index search and archive search. So just to reiterate, the functionality is exactly the same. We use the same search syntax. We set up everything exactly the same. The only distinction is if I know I need to go back further in time, I'm going to choose an archive search, and you'll see this icon changes to yellow, and then we can choose, we'll set up our time frame that is earlier than the index search period. The most common index search period is 7 days, but it is contractual. So if you're not sure, you can check on what you have for your account configuration. All right, so we talked about where we access those saved searches, and I did talk about the difference between index search and archive search. Again, in the way that we set up the search, there's no distinction. The distinction is really just the time frame that we're searching. If it's indexed because it happened recently, we don't need to change this setting, but if we want to look back further in time, we just change this to an archive search. Once we execute this, rather than getting the events just loading, we'll get a quick pop-up that gives us the search ID and points us at the archive search page to see those results. But it will also run, right, and kind of drive us to those results. And if we don't want to wait, we can navigate away and then go back. But you'll see we get the progress indicator here, and we get the time that it took to run. So almost the same workflow, just a little bit extra additional information because this search might take a little bit more time to collect depending on how far back you went. All right, so we covered a lot. Let me just kind of summarize some of the best practices for what we've been doing. We do want to use the taxonomy, and by that I mean indicating the class and metaclass. That's going to make for really efficient searching. I didn't do the best job of showing that in our examples because I didn't want our searches to be like super long and have it be unclear what we were pointing out. But you do, especially when you're going to get to the point of saving a search, adding the class or metaclass is going to make it a more efficient search. Use your proper syntax for field names. Basically, you got to get them right. If you don't have them right, you'll get an error. So it's pretty obvious. It'll just report, oh, that field name doesn't exist, and you'll notice the typo. That's one of the reasons that I often will find a sample event and build up my search from there, because then I know I'm getting all the naming right. Even though I've used the tool for a long time and I'm pretty comfortable with it. I'm very afraid of making typos. You can escape your text strings with quotes. So we saw that with the private IP address LAN. And in fact, if you're looking at our rules, you'll see most of the data that we have in there is escaped. It just makes it clean, and we know that everything is going to get interpreted exactly the way that we mean to. If you're using regex, anchoring that regex is going to be the most efficient by indicating the start or end of the string, if that's appropriate. And then don't forget about some of these features that I talked about for repeatability, like lists, favorites, and save search. So I hope in everything that we've talked through that seeing those examples gets your mind firing about all the ways that you can slice and dice through your data. I hope looking at some of those mechanics of favorites and save searches are going to save you time as you move forward and use the tool. I really appreciate your time today. A great time taking you through all of this wonderful tool set within Trellix XDR. Thank you so much for your time and attention. I'm going to hand it back to you, Nick.
Thanks, Sarah. As a reminder for everyone, Trellix Education Services offers exceptional training to go along with our award-winning products. If you would like to learn more, please visit the website listed on your screen to see all of our offerings. Now let's get our Q&A session started. I see we have several questions, but it's not too late to add your question. Please type it in the Q&A window to submit. Additionally, take a moment to fill out the survey. Your feedback and suggestions are always appreciated.
Can you put in a wildcard anywhere in the search string? What are all of the wildcard options? For example, is a question mark an option for a single character space?
So that's a great question. The asterisk wildcard is like the one shorthand that we have, and you can only use it in the start or the end, so as a prefix or a suffix. And then if you want to get more complicated beyond that, then you should consider using regex. So we support the full Perl regular expression syntax. And essentially, to use it, you're going to demarc your content with the slashes on either side, and then you have a lot of flexibility in the type of data that you're searching. We do recommend, if you're using regex, to add other fields and values to limit the data, because if you process a regex search, it takes more operational compute time as it churns through the events in the time frame. And so you can really whittle those down by adding like a meta class, or even like if you're trying to do a regex on a user agent, testing that that field has data. So with that has user agent. So essentially what I like to do if I'm constructing a regex search is either shrink that window of time down if I'm kind of crafting it for a rule, or if I'm doing it over search, kind of run the search first to get a set of events, try to get it down under like 50,000, and then start to apply the regex. That'll just be kind of more mindful of resources. And a lot of times, if I'm taking the time to craft the regex, I'm want to get the search right so I can reuse it in the future.
Got it. Okay, perfect. Thank you for that one.
Mm-hmm.
Can we run a rule or alert using data from within the JSON data?
Yeah. So any query that you can craft as a search string, you can adopt for a rule because the engine is essentially the same. So all of the syntax, like using a list or the CIDR notation, looking for using that dot notation, all of that translates very naturally to rules. You don't have to make any adjustments. So good question.
Got it. Okay, perfect. Thank you for that one as well. Is there a way to run reports or schedule reports from the archive database?
Oh, that's a good question. So the scheduling feature, I think, is going to be moving forward in time because once you essentially the functionality is you set up your dashboard, and then once you've got the dashboard, you use that cog menu to create a report or schedule it. If you wanted to run sorry, I'm just wanting to make sure I'm using the precise language. So for the reporting features, if you want to grab data from your archive, you would run the archive search, but I don't think there's not a way to do the visualization component of it. So you'd have to, you'd get the raw events and you'd have to do something outside of the tool if you needed to, chart it or do something visually. So you can do the data collection, over the archive time period, but the reporting, which is the widgets and the visualizations with the histograms, pie charts, bar charts, tables, that is moving forward in time.
Got it. Okay, perfect. Thank you for that one. With the archive search, how far back in time can you search?
So that is also contractually, but the most common configuration is a year's worth of data retention. We have flexibility, I think, up to 7 years. So it really depends on what your organization has arranged.
Got it. Okay, perfect. Thank you for that one as well. It looks like we've gotten to all of the questions for today's session. It looks like there's a few more questions that are about more specific topics. What we'll do is we'll collect those questions and follow up with you folks after the webinar. I want to thank everyone for joining today's webinar, and a big thank you to our presenter, Sarah. As a reminder, a link to today's recorded presentation will be emailed to all registered attendees. Thanks for joining today's webinar. Stay safe, everyone.
Bye, all.